As you all know, that part C is a team task, 3, 5, 4, 5, 6 members. I'm okay with that. And to respond to the question 13, you should tell me who are in the team, write down the names, and then what each of these team members did, their contributions, such as this person did the research, this person searched the internet, and so on. And any team member who did not contribute really significantly, just write down simply, that's all. Okay, now by now most of you probably have researched a lot about Bezier spline, idea of interpolation, and you realize that there are a whole lot of things online, and some of these things are really tough and you don't really understand what they're talking about. It is fine. And some of you probably have seen something used by the industry, by engineers, by graphic designers, and those methods are quite established. However, they might be too difficult for you to understand at this point. So, well, if you ask my opinion, I will say that just use your own approach, design your own approach, and then tackle use your that approach to tackle this problem here. And the I understand that I didn't ask you to give me like a perfect system, perfect strategy, as long as it works and is effective, because any limitation or advantages or disadvantage of your technique will be discussed in part 15. And I would advise that each and every one of you do your own conclusion, because this is where I know, and then number 15, writing your conclusion, how good you are understanding about the topic in discussion. So again, try not to use the methods you search online. They're quite difficult. Use your own approach, and then write your own conclusion, each and every one of you. And another thing is that you probably have seen the word B-spline instead of Bezier spline. Now, B-spline is not the same as Bezier spline. They are quite different, although they are related. So focus on Bezier alone. Don't look at B-spline, whatever Bernstein polynomial. You can understand and try that, but just focus on getting these questions done. Now, if you counted, there are actually 10 data set points, or 10 points where the coordinates are given. So I'm going to discuss two ideas. The first one is the idea of choosing quadratic or Bezier or cubic. So if you have a cubic here, okay, cubic Bezier, so understand you can opt for cubic Bezier or a quadratic Bezier. Of course, that's the power of 2 Bezier, cubic Bezier. And to do cubic Bezier, you would need 4 points to calculate all the coefficients and so on. Quadratic, you need 3 points. So let's just say you have a curve like this, something like this, and you know some of the points on the curve are given 1, 2, 3, 4, 5, 5. Okay. And so actually you can use 2 quadratic here. I show you why. Here you need 3 points to form quadratic. So here 3 points, these 3 points. You can interpolate this part of the curve, and then we need another 3 points to interpolate another quadratic Bezier to get a part of the curve. So for this part of the curve, we're going to do this also. We use these 3 points. And notice that this point is actually a shared point by both curves or both interpolations. So here there's one interpolations, and then another interpolations, and then that's why I call it spline. You know, we break them into 2 different arcs or 2 separate arcs. The key idea here is that at this shared point, or in the intersecting point where the 2 arcs meet, the gradient, this gradient here, let's say M1, and the gradient here M2, where the for this arc at this point, and for this different arc at this point, so they should be the same. That's why they're so special about this point. Let's suppose now you have a different arc, and now you have 1, 2, 3, 4, 5, 6 points known on the arc given. The coordinates are given. So if you try to use quadratic, so you'll be using these 3 points to interpolate this part of the arc, and this is something like a intersecting arc point. Then you use these 3 points to interpolate this part of the curve or the arc. But notice that there's a problem now. If you want to use quadratic, you can't, because there's only 2 points left. This is the one you use again, and this is a new one. So in other words, using 3 quadratic, 1, 2, 3 might not work here. To give you an idea, however, you can actually, on the other hand, do this. You can mix with cubic and quadratic, because cubic you need 4 points, so you have 1, 2, 3, 4 points. This is a shared point. If you're reading some of the notes, it's called a knot. The point where the 2 arcs meet. So then these 3 points, you can form a quadratic. So this is a cubic, this part of the arc, and this is a quadratic to interpolate this part of the arc. So you can see that it's not that always can use always all quadratic or all cubics all the time, and depending on situations, even like these two. So with that in mind, here you have actually 10 points. How you're going to cut this into different arcs really is depending on your decision. So I would like to see how you do that. Just one more bit to look at this. So here I have another arc, 7 points known, and if you think about this, you can do this with 2 cubic, so 1, 4 points, or and the other second arc will be another cubic. So this is a cubic Bezier to interpolate this part of the arc, and the second part of the arc you use in a cubic also. Of course, notice that some of you who have sharp eyes will probably realize you can also use 3 quadratic Bezier to interpolate this. I mean, you keep it into 3 different splines. Okay. Once you have decided what to do, how many splines you want to do for interpolations, you come to this problem here. You have equations, system equations, and they look something like this. System equations, they look something like this. Because I show you why. If you go to this part of the textbook, you will find this particular formula to find the coordinates of Bezier curve, any point, the x and y, and the coefficients ax, bx, cx, dx, and so on, ay, dy, by. They define as follow. So I've written this down here. Another thing you notice is this, and here you have this the equations of x point or x coordinate, and say you given the values of x being a negative 18.5, and also you know that another x value is say negative 3, x equals to 3, and then x equals to let's say 3.41. So what you can do is you substitute all these 4 values into this equations, this cubic, and you get 4 equations, right? Alright, and then you may use this to form some 4 lines equations. However, this approach is actually not easy because it requires high advanced knowledge of linear algebra, and you're seeing this here in under matrices. But you need something more than that, than this elementary row operations and so on. So that's why I would say that you try to avoid doing this until you reach a stage, okay, you think you need linear algebra, there's something that within the mathematical studies syllabus, yes, go ahead. Anything you find troubling, do not attempt that, because it will take up a lot of your time, I guarantee you that. So I end with one suggestion. Some people would like to do this actually. What I'm trying to say is that using linear algebra approach, or like the matrix approach, it's quite effective, but it might be too much for some of you. So if you want to try that, go ahead, because there's a very nice paper here. This paper here written by these 2 scholars, Nanyang, the NTU, and they explain very nicely what the 2 steps curve fitting. But simply what I asked you to do actually, but it's really tough. But if you can handle it, yes, go ahead by all means. But otherwise, you have options here. I'll give you an idea, just a simple suggestion. Say like there are 3 points here. Now we know that these 3 points, especially this one, they are not the end points of this curve. So you can't really use a quadratic Bezier because you don't know the start point and end point, and of course you don't know the control point. But you can suppose they be the end point, and then you extend that, and there will be a very nice fit too. That's an idea. So you can just take this this one instead as the start point, and this point here as the end point. And although there's one bit here, you notice that this bit here is not really inside the point, but it will be a good approximation also. So when you do the spline, you cut it into different arcs, you might think of this way. So I might not I don't want to add more to this, but one more thing you need to ensure is that, say at this point here, this is where the two meet. So you take these 3 points to use quadratic, just for its examples, alright? And these 3 points then use quadratic. So you have this 1 point, 2 point, 3 points quadratic, 1, 2, 3 quadratics. So these two arcs will be interpolated by a quadratic Bezier. And understand, you may mix quadratic and cubic if you want to. Anyway, back to this. So you notice that right here, this is where the two arcs meet. You have to ensure that the gradient or the slope at this particular point, let me take this away, this particular point for this arc, if you use this arc, will have you get a gradient, say m1. And if you use this particular arc right here, and you calculate the gradient for this point h, the point h, you get another m, something like m2. Now if your interpolations and your spline is really good, you will find that m1 will be equivalent to m2. It must be because it should be a smooth curve, even at this particular point h, where the two different arcs, you join them together. Okay, the two different set of equations here, right here, the one on top, and this arc at the bottom. When you join them at the point h, this should be like very smooth, like when you draw smooth like this. Otherwise, you get a situation like this. You draw, and the point h, because if it's not smooth, you get something like this, and or something like this, and then something like this. So it's not smooth here. Okay, so take note of all these things. Any questions, just text me, okay, message me via at Modo, and I'll try my best to respond. All the best.